Hey, it's Sparky 4 guy, and today we're going to be replacing a light switch. I will show you why. See, what if you can hear that hissing and popping? That was what the kids complained about, and that got me concerned right away, obviously, because that hissing and popping is internal arcing. And what can happen with arcing is it can generate heat, which could ultimately lead to a fire. So this switch needs to be replaced. This is part of a three-way circuit. So there's a switch here and there's a switch over on the other wall that both control the same light. So if I flip the other light switch, notice the light did not go on. It should have. And now if I flip this, you can see it's flaking out. So there's definitely a problem with this switch. It is not transferring the electricity properly internally. So time to replace this switch. First, let's review some typical household light switch configurations. This is a single pole, single throw, or SPST switch that controls a light or other device from one location. The switch controls power to the device by making or breaking the electrical supply through the movement of a single set of contacts. Electric code allows for a couple of different ways to wire this type of switch. This is an inline configuration where the power feed enters the electrical box housing the switch before traveling to the box with the device. This is an end-of-line configuration where the switch tees off from the box containing the device. In this case, a single cable enters the switch box, and the white neutral wire is repurposed as a switch hot and marked with some black tape. A three-way switch configuration allows a light fixture or other device to be controlled by two switches, which is commonly used where you may have a switch on either end of a staircase or a hallway. A three-way setup uses two switches, each with three contacts. These switches are single-pole double throw, or SPDT, because they have a common contact that is electrically connected to one of two contacts, depending on the position of the switch. Wiring a three-way switch typically involves three-conductor cable where a black, red, and white wire are used. These two switches enable two of the wires, called travelers, to provide a flexible path for the electricity to flow to the device. In order for the device to receive power, both switches have to be connecting their respective commons to the same traveler. Otherwise, the circuit will not be complete and the device will be off. Alright, so here we are at the breaker panel. Now, normally, the breaker panel should be labeled for what each circuit is. Whoever wired this house, they should be fired. No labels, no nothing. I went and labeled a few things here, just the main, the 240 volt breakers, but these other breakers are not labeled at all. No idea what they are. So here's what I did to solve that. I drew this when we moved into the house back in 2004, and what I did is just walked around. You flip a breaker and you see which devices are impacted by that breaker, and then map it out. So this is kind of a semi-scale drawing, but you could see now just visually that if I wanted to turn off this outlet in the master bedroom, I would flip breaker 7A, because having the panel just say master bedroom is misleading, because notice this outlet is 5B. That's why I generated this drawing, because now visually you can see, especially when you have more than one circuit in a box. Now this particular circuit that I'm going to be working on today is right here, and you'll see that this light is on circuit 9A, whereas the family room lights are on 7B. So I need to shut both of those breakers off to make this box safe to work in. Okay, so per the diagram, we need to turn off 7B and 9A. Visual indication. The light is now off, and this light is now off. Start by removing the cover plate. Try not to drop the cover plate. They don't like that. Then, remove the screws holding the switches in place. Note, on this installation, the hole in the paneling was cut too large, so scraps of paneling were used as spacers to keep the switches out far enough so they align with the plate. Gently pull the switches out of the box. Check the wires as you do so to ensure they do not snag on anything such as screws or retaining brackets within the box that could damage the installation. For extra safety, Use a voltmeter to verify that the circuit is dead. I checked between the grounded metal box and each line to ensure there was no voltage. Of course, be sure the box is actually grounded in your case. If not, you may need to find either a dedicated neutral or ground wire within the box to touch with one of the meter probes. Be sure your meter is set to AC voltage. Here are the replacement parts. I have two Decora Series 3-way switches. You can tell they are 3-way because they have one dark terminal and two brass ones. I also bought a 2-gang Decora Series plate. I'm going to do these one at a time so that I don't confuse the wires. To save some time, I used the power screwdriver to completely back out the screws from each switch, as I did not plan to reuse the switches. So here's where I get to have the deer in headlights reaction. I backed out the screws on the old switch before I took note of which terminal is the common. I have learned over the years not to trust that people who previously wired devices did them correctly, so assuming the correct wire colors were used is a bad idea. Using the resistance setting in the meter, I verify which terminal is the common on the switch because there was no indication on this particular switch. And that's one of the travelers. And if I go to the other side, it's the opposite. So this is the common, and these are the two travelers. So on the new switch, you'll see that it's slightly different in that the two travelers are diagonal opposites rather than straight up and down. So I am dealing with a metal box here with BX armored cable. There is no dedicated ground, so this terminal will not be connected. So I will just take this and tighten it up. As you may have seen in the table lamp and lamppost repair videos, wrap the wire along the screw in the direction the screw tightens, which is clockwise. This ensures the wire does not get pushed out of the connection as the screw tightens. Since I had backed the old screws completely out, I use a plier to gently open up the loop in the wire before wrapping it around the new screw. Once in place, close the loop to ensure the wire stays under the head of the screw. Use a hand screwdriver and do not over-tighten the screw. Go slow and make sure the wire stays aligned with the terminal and wire guide if the device is equipped with one. You want to make sure these are snug. Don't crank the crap out of it because you don't want to break the switch body. The white wire was stripped a little long. This was remedied by trimming a little of the extra with a pair of wire cutters. Okay, and that one is on. I'll go ahead and do the same thing with this switch. Remember that some 3-way configurations will have two black wires connecting to the switch. The one connecting to the common would be either the feed coming from the panel or the switched hot supplying the device. The other would be one of the travelers. This wire was on the black terminal of the old switch, so it's the common. Just use patience. Give a little adjustment and get it on there. I'm going to take this opportunity to swap the switches within the box as well, since the left switch currently controls the light on my right, and the right switch controls the family room to my left. It actually makes more sense. So it looks like the reason they did that is the circuit for this light is coming in on the left side of the box. I don't know why they who was thinking whenever they wired this house, but sometimes you gotta just shake your head and go, what the hell? So just make sure we have our kind of S curves on the wire so it doesn't stress the battery, so it doesn't stress the terminals. Just trying to get these wires pushed back so they're not binding up on each other. Okay, so everything looks good. Let's secure the switches and refit the paneling spacers. Okay, so here's one of the hazards of working on electrical things when you are distracted. I'm busy focusing on trying to make sure the video's got a good angle, that you can see what I'm doing, and I messed up. Here's the problem. When I took off the old switch, common, traveler, traveler. When I put the new switch on, this was the black, this was the white, and this was the red. Black and white are supposed to be the travelers, red is the common. I swapped the black and the red. So, easy fix, I can take care of that. Okay, with my mistake fixed, we now have a working set of switches. So I hope you learned something with this video, hope you enjoyed it. Also saw what happens when somebody messes up, but in any case, problems resolved, new switches are in. So don't forget to hit that subscribe button, hit that notification bell as well, and that way you'll know when I post new videos. And check out my other do-it-yourself videos and make any suggestions in the comments on how I can do things better. And until then, this is Part 64 Guy. Thanks for watching. See you later.